Hello. Hello. Yeah, I think it's fine. Yeah. Let's get started. I think. Yeah. So there are a few topics from PIB and then some other topics. Okay. Yeah. First is this NPPA integrates Pharma Jan Samadhan portal with Pharma Sahi Dam portal. Now, you understand a little bit of Hindi? Huh? Little. See, these words mean what? Pharma, you understand? Okay. Then Jan. Jan means people. Samadhan means solution. Okay, so basically this is providing sort of pharma solutions to the people, correct? So this is Pharma Jan Samadhan portal, and similar is Pharma Sahi. Sahi means correct, Dam means rate or price. So this is telling about the correct prices of different pharmaceuticals. Okay, now so these two have been integrated. There used to be two different portals. Main use case is same, that is pharma pricing, people's participation in pharma pricing enforcement. Okay, so if there are some discrepancies here there, so then people can report that this medicine is being sold at this price, which is much more than the stipulated one, correct? Now here one very important thing is basically how entire pharma sector is managed. Okay, I'm expecting a question on this from a long time. Let's see when it comes. So this is the okay. Yeah, so this is pharmaceutical regulation in India. Now there are different components to it. Now the first component is this. Yeah, first component is this CDSCO. Now what is this? This is Central Drugs Standard Control Organization. So this is an organization under Ministry of Health and Family Welfare. So basically what it will do, it will do testing of different things, approving new drugs, that this drug is safe, clinical trials of it, all those are done by CDSCO. Now After that, you have state drug controllers that are under state government. They will give licenses to manufacturing plants where they have to be manufactured. Then they will follow all the standards that has to be followed in the factories. All those are ensured here. Factory inspections, all these are done at the state level. Now, the third stage is actually pricing. So here it was testing that if some drug can be allowed to be sold in India. Okay, clinical trials and all that. Now, here what you have is pricing. Now, pricing is under another authority called National Pharmaceutical Pricing Authority. Okay, this is the same authority for which you got those two portals unified. Now, this why this authority is important, because this is not under Ministry of Health and Family Welfare. This is under Ministry of Chemicals and Fertilizers. Okay, so it can become a trick question because the regulation here, everything you relate with pharmaceutical, you usually relate it with health ministry. Now this is from Ministry of Chemicals and Fertilizers. Why? Because essentially whatever medicines we are making is basically chemicals, and what should be the price of a medicine depends on what are the prices of the constituent chemicals, and that is why it is given under this. Now, so this fixes ceiling prices of scheduled drugs under DPCO. Okay, we'll understand how this works. Then you have state control departments which will provide licenses to wholesale drug selling like medical stores and all. So those all are done. Now the last is safety and ethics. This is again under Ministry of Health and Family Welfare. Now what is done here? Now let's say you get to know later that some medicine is causing this issues, correct, or some wrong versions of it are being sold. So then who will enforce ban? So this actually bans unsafe or irrational drugs. Again, Ministry of Health and Family Welfare. It also issues safety directions like these. Like example, you know about DDT. DDT was later banned. There are many medicines, okay, that are later get banned because of some new things that we get to know about the side effects. So this banning is done by this. Only the pricing part is actually given to this authority which comes under Ministry of Chemical and Fertilizers. Now, let's see this. So it says, so this is a significant step in this. What they have done basically, this is to strengthen citizen-centric digital governance. The National Pharmaceutical Pricing Authority under Department of Pharmaceutical, Ministry of Chemical and Fertilizer has integrated Pharma Jan Samadhan portal and Pharma Sahidam portal. Both have been combined. Okay. Then it is telling you a bit of detail about this NPPA. So this authority was made by a government resolution in 1997. Okay. Now this comes under Department of Pharmaceuticals. Okay, 1997 by a government resolution. Now, one more thing. Here is this. Why it is getting stuck? Wait, I think it's. This one is smoother. Yeah, now it's fine. Yeah, so by a resolution in 1997, ministry and all, you understood. Now what is this? This is an independent regulator of pricing of drugs. Okay, then responsibility of fixing. Now see this term. This is again one thing that we have to understand. So it has been entrusted with the responsibility of fixing and revising drug prices as per the provisions of Drugs Prices Control Order. So this is DPCO 2013. So NPPA regulates prices of all these medicines under DPCO 2013. Okay, now understand what comes under DPCO 2013. Of course, not all medicines, everything will be covered here, correct? So what comes under here? Understand this. See this. Now, there are actually two classifications. One is called essential medicines. Essential medicines are those which Ministry of Health and Family Welfare has called them essential because they are very important for example, all those important antibiotics you hear of, correct? They are very important. So all those comes under essential medicines. Now, all the essential medicines also come under those scheduled medicines of DPCO, which NPPA regulates. Now, there are some other medicines also that can come here that are not essential, but for example, during COVID, there were some medicines, correct, that became very important. So those prices had to be regulated. So those prices had to be regulated. So those are scheduled, not essential, but they are scheduled. Everything that comes here in this black circle, including all the essential ones, are regulated by NPPA for its pricing. Now, every year, NPPA annually revises ceiling prices of essential medicines based on WPI. WPI, you know, wholesale price index, one kind of price index. Based on it, it releases the ceiling price. Okay, fixed price is not there, but they usually give, like for the generic one, this is the price, and what is the maximum amount at which you can sell this, and it should be within this range. If it is not within this range, then people have those grievance redressal in which they can file a complaint that they are selling me, for example, amoxicillin at this price. Understood? So this is what is done, and all these drugs that are regulated by NPPA are called scheduled drugs under DPCO. That is under schedule 1 of DPCO, or they are called scheduled drugs under DPCO. Then next, now understand this. This is again important news. So basically what has happened, see, this is DAE, what was it? Department of Atomic Energy, correct? Now, we had also talked about that recently fast breeder reactors, that is the second stage of Homi Jahangir Bhabha's 3-stage nuclear plant, that has achieved criticality in Kalpakkam. Okay, now, so that you had understood. Now, here there is no use of it, but the thing is that using that energy that is coming from that fast breeder test reactor in Kalpakkam, what they are essentially doing is, see, you know, hydrogen is very important for production of many things, correct? For production of all kinds of fertilizers, even in steel plants, okay, all these places, hydrogen is very important. It is one of the fuels with very high calorific value also. Now, so you want to produce hydrogen. Now, the thing is that if you take, for example, water, now you break this water into H2 plus O2. From this, what you can get? You can get hydrogen. And also to burn hydrogen, you need oxygen, so you get this also. But this is not a very easy process, as in breaking down this water into hydrogen and oxygen requires a lot of energy. So what you need to fill here? You need to fill here a lot of energy. Now, based on where this energy comes from, you get different varieties of hydrogen. Okay. Now, for example, you might have heard of, this year there was also a question on this. What is green hydrogen? What is green hydrogen? So green hydrogen is when water is broken down like this to release hydrogen and oxygen, that is hydrogen is produced, but that energy that you are getting here is coming from renewable energy. So then it is a very nice process because you are using renewable energy and you are getting hydrogen, which is a very good replacement for fossil fuel based things. For example, through hydrogen you can run even vehicles and everything. Correct. Now instead of this energy, if it comes from, instead of green hydrogen, if it comes from nuclear energy, then it is called pink hydrogen, or in some countries purple hydrogen. Now this is also very good. Why? Because nuclear energy also does not release any kind of greenhouse gas emissions or this that. It is also a clean fuel. Correct. So now you are seeing the connection. So what is being done here? The reaction is not as simple as in case of breaking down H2. Here the reaction involves copper and chlorine. So the reaction is much more like CuCl and then 1,2 intermediate product. Eventually you will get H2NO2. Now read this. DAE inaugurates world's first hydrogen production facility, correct, based on copper chlorine thermochemical cycle. Okay, so that is the whole reaction that is going on, copper chlorine. Now using what? Using nuclear heat or nuclear energy from fast breeder test reactor of Kalpakkam. This is what we have been able to achieve, and that is why this is very important. Okay, this year's question was first asking about what is green hydrogen, and then they had given a wrong statement. So from that only, I think 2 options were getting eliminated. One more statement was what is the target for us. So that was 50 MMT something was given. So that was correct. So that way they gave a question. Before that also, I think in 23, in 24 there were again 2 questions from hydrogen. So they keep asking this, different kinds of hydrogen and all. Now yeah, so this Indira Gandhi Center for Atomic Research, Kalpakkam. This is what it is called. To that fast breeder reactor that you have, there only they have showed this. Then yeah, so the process significantly reduces dependence on fossil fuels and eliminates greenhouse gas emissions associated with conventional hydrogen production method, because conventionally it is actually taken out of natural gas. So we use natural gas, okay, plasma gasification, coal gasification, and from that we get hydrogen, which is not very sustainable, okay, environmentally. Then this is given about IGCAR. So this is India's premier nuclear research institute, established in 1971. It is the one that was pivotal for this prototype fast breeder reactor at Kalpakkam. Then last, reinforces India's resolve to build sustainable, secure and low carbon energy future for Viksit Bharat. Okay, the reaction, see, reaction is not important. I am just telling you, so you know that this is not just breaking down of H2O. So the reaction, you need not even write the reactions. Okay, this goes like this. Something like this. Then yeah, I'm not balancing the reaction, you just focus here. So basically what happens, they take, can you see copper chlorine, so CuCl2 plus water. Now it will form some intermediate compound like CuOCl like this, and you will get HCl. HCl is hydrochloric acid from this. Now after that CuOCl, if you keep heating it, you can get oxygen out of it. This is what we wanted. Then some CuCl is released, but copper usually likes to stay in +2 form. So CuCl, if it reacts with HCl, it will become CuCl2. So Cl is gone. What is left? H. So if you take two HCls here, you will get H2. Correct. So essentially all these are intermediate compounds. If you see here, CuCl2 was here, CuCl2 is here. Correct. So that you have gotten back. So essentially what has broken down? This H2O has broken down into half O2 plus H2. Understood? Okay, just have an idea. Please don't remember it. I also don't remember like how exactly it has to be balanced. I can, but it doesn't matter. Okay, then. Yeah, this is also a simple thing, but good to understand. See, this will also help you when you are prompting LLMs. This is AI and temperature dial. Now, understand this. There is a term called hallucinations. You know what is this? Huh? What is this? No. For the AI hallucinations. AI hallucinations. See, you can try this also. Take the basic version of ChatGPT, no pro, nothing, and put a document of like 200 pages and ask him that on 163rd page, what is the third paragraph? Please explain me. You will find that it will just start telling you something. Now, it has of course not gone through the document to that particular page, to that particular paragraph in such limited time within a few seconds. It has not gone through it, but it is giving you result, correct? Now, this is not based on what data you have given. So this is called hallucinations for AI. So AI actually does not understand your document, does not have it in its memory, but is somehow just giving you information. Like you have in hallucination, it does not exist in real, but you start to feel it. The AI also feel that I have understood it and then starts generating content. Now this is a major issue with respect to AI, because see, we are doing it, we can call that you are saying anything, this, that. But if you're doing it at a company level, what if it starts hallucinating at some critical step and nobody realizes it? Correct. So that is why AI hallucination is a major issue. Now, what this thing has come up with, so this is actually a known phenomena. Recently it came in the Hindu. Okay, so that is why it was in news. Now understand this. So AI hallucinations, you understand. Now, you understand this term also, creativity. Now creativity, what we create, creativity is never about the most efficient, the most perfect way, correct? Creativity is basically little absurd. Okay, it goes here and there, and then only you can create something new, correct? Now for example, the music that we create, it is not about the like what is the shortest note that can be played, it is about what beautiful patterns you can find. Now as we are employing AI more and more to generate creative content, or to for it to act creatively, we have seen that it hallucinates more. Now why does that happen? Understand that. So this measuring is called temperature dial. Okay, so temperature dial. Now see, when working with LLMs, temperature acts as a creativity dial, controlling how predictable or adventurous a model's responses are. Now, if the temperature is 0, that means what? It is completely fluctual. It will not go here and there. It will just give you the result directly, the perfect result, but directly. But it will not create the things that you want, or tailor made, much better tailor made for you. For example, if I ask it, let's say now, one way, if this temperature is 0, it will give me the exact answer. Okay, whatever is the exact answer. Now, if the temperature is slightly more, for example, let's say the temperature is like 0.5, let's say 0.5, 0.7. Now, what it will do? Now, it will understand that somebody who is asking this, okay, he does not want the answer. Answer he can get from anywhere. So I must give him some clue also, that how I have calculated this or how you could have done this. So then it will give you the same answer, which is the correct answer, but it will also tell you that you can do it like this. Correct? This you might have seen that when you ask question, sometimes it tells you. So basically now what they have done, they have dialed it little above so that it also gives you much more information. That is why you have a study and learn in that chat GPT, you have study and learn pattern. So there, instead of giving you full solution, it keeps giving you this. Correct? Now, if I increase the temperature to very high, correct? Now, let's say the temperature I turn to like 1.2. Now it is highly creative. Correct? So what it will do, 24 into 99, it will give approximately, this is 2400 and it will give you plus minus something like this. Correct? So basically here it is not being very strict. Here it is being creative. Like 24 into 99 can be thought of as this like. Okay, so this is what is does when you increase the temperature. Now, as you can see that if instead of these numbers, you're asking something much more like natural, like you're talking about something something creative, like what are the different chords that you have in a guitar. Now here the temperatures will matter a lot. If temperature is 0, it will list all the chord. If temperature is slightly higher, it will tell you more. Here it will start telling you some patterns, this that. So now you understand that both are required, but the problem is as you increase the dial, the creativity matter will increase, but it can start giving you factually incorrect answers. Okay, and this is what they are trying to resolve right now. This is a major issue that they have. In fact, if your AI is not giving you very correct answers, you can ask it like factually correct answer. You can ask it at what temperature you are working right now. So it will tell you that I am working at this, then you can ask for this. Other thing is you can simply ask that give me citation of everything that you give me. Now, if you understand all this, see, so what is temperature? Temperature is a parameter in LLM that controls the randomness of word selection during text generation. Now, so here what is happening? For example, let's see. Now, when we learn about LLMs, we will learn this pattern where what it does. For example, chess is a, what will be the next word? What LLM does, it search all the things that it has in the internet. On the internet, it will search all the documents, this, that, and eventually whichever is the most probable, that word it will enter here. So chess is a, let's say, game is more probable, has like 50% probability, and the other sport has only 20% probability, or let's say 1%, let's say 2% is the possibility of calling it a waste of time. So the next word, calling it waste, is like 2%. Now, but AI understands your context. So what happens if you are talking about it, about your chess addiction, that I'm all the time playing chess, not able to concentrate anywhere else, I cannot study because I keep playing chess. Then if you ask it that what do you think chess game is for me, so then it will tell you chess is a waste of time for you. Correct? So essentially what it is doing, it is increasing the randomness. It is not giving you the most probable answer, it is giving you the most pertinent answer based on your context, and that is why temperature is important also sometimes. So here what happens, so the randomness of a word selection during text generation, this is controlled by temperature. This is like a creativity dial. Now low temperature chooses the most probable next word, correct, the exact thing. High temperature explores less probable word choices. Okay, if you just understand these terms, that much only is enough. Right? What is temperature? What will happen at low temperature? What will happen at high temperature? That's it. approximately, so it goes like 1.2, 1.3, that also. Now, this is again can be used as one of the statements. So does it affect intelligence as such, that if you increase it then it becomes dumber or it becomes smarter? No, nothing like this. This is not about intelligence. This temperature does not change the model's knowledge or reasoning ability. It only influences how consistently the model generates responses. That is why it is 4. Then importance is low temperature is preferred where accuracy and reliability are essential. High temperature is useful for creative writing, brainstorming, storytelling, correct? Because if that element is not there, then it will not be able to generate anything for you new. So a balanced temperature is needed that offers a trade-off between creativity and factual accuracy. Yes, yes, you can. You can ask him and he will start working on it. Okay, but again you have to check, because the base models that you have is, so they provide very less tokens to it, so it just wants to generate anything. So try to use it in different modes, like you can use the think mode. There is also Gemini has pro mode, pro extended. So try to use the better engines and then you will mostly get the right results. Okay.
Creativity as a separate feature,
Yeah. So actually,
where we can adjust the temperatures.
see, actually, if um, there are different modes, have you seen? So basically, if you go to Gemini, it will tell you that this extended is very good for mathematical calculations, and then the other one it will tell you that it gives the best responses for general queries. So there, the temperature is different. Okay. Similarly, you have study and learn. That is another. So that is why they have different. Now, otherwise, they can also make one model which is the best model, let's say, and provide it to everybody. But this dial they are trying to provide you. Okay. Then.
So just a small note. So when they're customizing it to, for example, different sectors, for example, in medicine,
Yeah.
AI in medicine or
Yeah.
AI in education,
Yeah.
do they again like regulate the temperature and then?
Yeah. So right now this connection has been found. Okay. And of course they are regulating it, but the problem is that um the problem is like you need little higher temperature dial to get certain results out of it, because higher dial also gives you more contextuality. Instead of uh, just giving you the perfect reply, it gives you the more aligned reply to you. Now that is why companies, they need little bit of temperature also, but that temperature, when the temperature is increased, it leads to hallucination. So right now the major issue is finding that balance out for each industry, for each company, like that.
Don't you think it's a little dangerous in the medicine field?
Yeah, it is dangerous in all the fields. It is dangerous in all the fields. Okay, so right now that is why companies are like testing it. Like many times it has hallucinated and causes issues, but they are usually running it in the trial way. Okay, because even for Amazon, if it is not let's say not cataloging things correctly, then wrong things will be packed, because it is completely robot operated now. Correct. So something else will be packed, something else will be sent, anything can happen. Correct. So major issues can be caused. That's why you still have those engineers and everyone who's doing all this backtracking, that everything is working fine. Okay. Then one more topic. Hmm. Okay. Now, so there is one huge crater. Okay, crater, you understand? So basically some celestial body like asteroid, meteoroid, when it hits the earth, it can create depressions. Those are called craters. Now, craters have one crater, it was known for a long time. So basically the age of this crater is sort of disputed. Okay, so some new study has come telling about the age. That is not the main topic that I have chosen. So I will be telling you about different, like first of all, how this whole system of dating works. And the other thing is what are important structures that are formed or craters that are formed in India. So those four we will try to cover. Now, so this is huge crater in Australia, maybe Earth's oldest known impact site. Scientists disagree. Now, let's see this. So first is this North Pole Dome or Myrelga crater. Now, first of all, this is not Pole Dome. Don't get confused. This is in Western Australia. Okay, now, so this is one of the oldest known asteroid strike site on Earth, and new study saying that it will be around 3 billion years old. Only this much is what you need to know from here. Okay, now let's first understand what are all these terms. Yeah, let's understand this. Yeah, let's see this. First term is comet. Now, what is comet? So comet is basically rock is there and rock and ice mixture. So there is a chunk of ice and rock. Now what happens, because there is ice also, rock also, now when it goes closer to, let's say, sun or any star, now it has a lot of heat that is being produced. So suddenly this ice gets converted into water vapor, and that is why you see a tail like structure behind the comet. Understood? Because water is getting evaporated constantly. So this is what you see as a comet. Now the other is called asteroid. So asteroid is a very large rock. Okay, it may have some minerals, it may have some metals. It is basically a large rock. Now this is specifically mostly found in asteroid belt, that is between Mars and Jupiter. Okay, very large size rocks. This is asteroid. Then now next term is meteoroid. Now meteoroid is what? Basically when these break down, small fragments of this. Okay, so this is a space rock that's bigger than a dust grain but smaller than an asteroid. Correct? So basically what is meteoroid? Just smaller versions of this. Okay, whatever are remaining after a very long time, slowly it keeps losing mass. Sometimes it collides and these are released. Now these three are still in space. Now sometimes what happens, you might have heard that one asteroid is coming towards India, towards Earth, like this you might have heard. Now this is what happens in the atmosphere when it is trying to enter Earth. Now the Earth's atmosphere has very high air resistance and friction, because of which what will happen, let's say this meteoroid tries to enter here. Now friction can burn things. Have you felt this? Correct. For example, when you fall, so because of that heat only the skin burns. Correct. So now same thing happens with this meteoroid also, and most of it is completely destroyed in the atmosphere itself. So you will just see it as a shooting star or something like this. So some glow you will see and it is gone completely. So this is like a falling star that you see. Now this is called a meteor. Meteor is anything, the streak of light seen when space rock enters the atmosphere and starts burning up. This is meteor. Finally you get to something that we know as meteorite. Meteorite is something that strikes the earth surface. This will cause those craters, depressions, whatever you want to call it. So this is if a meteor does not entirely burn up, a piece of space rock that lands on earth is called a meteorite. Okay, so don't get confused by the terms. Now sometimes what happens, sometimes the meteorite that hit the earth is actually so big that they call it sometimes asteroid. So don't get confused by it. Essentially anything that hits the earth's surface can be called a meteorite. Sometimes it is like 1 kilometer long. Okay, that is essentially the size of an asteroid. Maybe it came from a much bigger asteroid, that's why the size reduced, but still it was very big. So then they call that when an asteroid hit the earth's surface. So these are the different terms: comet, asteroid, meteoroid, meteor and meteorite. Okay, Now see this. So this is the oldest one that we think we have found is 3.2 billion years old. Now why is this discovery important? Because earlier age estimates used to be something different, from 3.47, that is something more, to something less also. Now this is a much more accurate study. We will understand why I am saying that this is a more accurate study of age. Okay, now here, from here, the factual version, just these three things. This is the crater, this is where it is located, this is how many years it is old. That's it. Other than that, nothing. Now, key facts. So this is by an asteroid impact that stretches up to 100 kilometers. Now 100 kilometer stretch does not mean that it was 100 kilometer large. It was 1 kilometer only, but because it came at such a high speed, that is why when it fell, it affected rocks till 100 kilometer radius. For example, when you jump in swimming pool, correct? You jump for a very small area, but the entire swimming pool, if you are heavy enough like me, then the entire swimming pool will move, correct? Same thing happens here, correct? Now, what are this zircon and apatite in geology? So these are the two mechanisms that we used for dating. Now let's understand them. So in nuclear energy, when we do, so uranium you have heard, correct? Now uraniums are contained within fuel rods, within fuel cells. Now those cells which contain uranium are made up of zirconium metal. Why zirconium? Because zirconium has a very high melting point, a very high melting point. Now, so this zircon is actually one of the compound of zirconium only. Now, how dating works, understand this. Okay, so basically what happens, this, now zircon has a very special property, that when it first time crystallizes, when it is first time formed. Now when will it be first time formed? Basically when something fell. So because of that, what happens, all these rocks get crushed into each other. Now this crush is not normal crush. Basically they crush so hard that it leads to formation of sometimes new kinds of materials, some very new compounds. For example, zirconium, let's say, does not bond with sulfur that well, but if so much heat is provided, suddenly that reaction happens and suddenly you have a compound, correct? So those things that we do in factories using heat and all that is anyway provided here, correct? So very different compounds are formed here. Now, so this zircon has a special property that when it for the first time crystallizes, it only takes in pure uranium in it, only pure uranium. Now over a time, when after many years we plug this out and we see that how much uranium is now there, how much is pure uranium, how much it has converted. Now because uranium goes through radioactivity, so that rate we know that every few years it loses this much, every few years this much is converted. Through that we backtrack that how old might have been that strike. Understood? Now the other part is apatite. Apatite is basically phosphate groups from which your enamel of your teeth, bones, correct, the outer layering, that is made. So now apatite has a very special property, that apatite actually melts very easily and it flows. Now, so based on, so this tells you about when it must have struck and what impact it has caused. For example, it struck only in 1 kilometer radius, but the impact would extended to 100 kilometers and the impact would have been slowly some more impact you must have seen, correct? Over time some new compounds, this that went on. Now who will give you that dynamic nature, that how things changed? That is calculated using flow of apatite. So this gives you the initial, when it struck, apatite gives you how is the flow or how the changes occurred. And together this is called zircon apatite study together, and that gives you very accurate results. Now yeah, so zircon is called indestructible record because survives extreme heat and shock. It traps uranium and rejects lead, allowing accurate uranium lead dating. Then appetite, thermal record, is heat sensitive and records the heating and cooling caused by asteroid impact. Correct? Now, why they studied it together? You understood? One is for when and then how. Then how does the new study suggest overall? So it gives you the more accurate claim that this might be 3.02 billion years old, which makes it one of the oldest strike that is known to us on Earth. Then now last thing that we have to see is craters in India. Again important, there are 4 craters. Okay, I don't know, actually this is a topic that is not very well covered in geography also. So basically this is a very specific topic, you just need to know these 4 names. Now what is this? This is craters. So crater you have already understood. What is a crater? These are impact structures. Now there is Dhala crater, this is in Madhya Pradesh. Now this is the largest confirmed impact crater in India. The largest, so this is the largest as well as oldest in India. Then first see this Ramgarh crater, nothing much about it. This is again in Rajasthan. This is known for because it fell on sedimentary sandstone, sedimentary rocks, you understand, igneous sedimentary rocks. So it fell on sedimentary rocks. That is the only thing. Here you just remember Ramgarh crater, Rajasthan. This is important, which is Lonar. Now, what is this Lonar crater? So what happened? Lonar crater is actually a lake. So what happened? It struck like this and it created a huge depression. Over time, water filled here. Now, the thing is, why it is so different is basically all the lakes and everything that you see now. So usually they have subsurface water flow. Correct. So lakes also, the natural lakes you might have seen that they remain clean. So they have a whole mechanism. Correct. Now the thing with Lonar crater is, or this Lonar lake is, because it was formed by a sudden impact, it does not have any connection. So it has no outflow, it has no inflow. Inflow of course from rainfall and all you have, but not from any river or nearby any water body. Similarly no outflow also. Now what this creates is basically, and this is in Maharashtra. So Maharashtra, a lot of heat is there. Now during the summers what happens, there is a lot of evaporation. Now in 2020 it was so much, in 2020 this lake actually turned pink. Why it turned pink? Because of a creature called haloarchaea. Halo means salt. Okay, so what happened? All the things evaporated. Now if you take salt water or anything, then water evaporates. What it becomes? It becomes more and more salty. Correct? Same thing happened here also, because the water levels were so down. That is why it became very basic in nature. Now when it became very basic, this particular archaea or bacteria started growing here and it develops a coating above it which made the lake pink. But it was not a permanent change. Again rainfall was there, the water level increased, the basic nature decreased and it became the normal green again. Then again it didn't become pink. Recently it has not become. So this was in news then. So this is Lonar crater. This is world's only impact crater formed in volcanic basalt rock. This is also fine. Now this is 52,000 years old and this is very famous for what? As I told you, the bacteria, that is, it is very famous for microbial colonies. So many different kinds of microbes and all live here. Then the last is Luna crater. This is recently confirmed, in fact only in 2024. So this is in Gujarat. So this is in Gujarat, or to be more precise, in Kutch region of Gujarat. Okay, so this sees unusual high pressure and many different kinds of minerals are discovered here. If you just remember the names and very basic thing about them, that this is just in 2024. This you need to know a little more in detail. This is the largest and oldest. Ramgarh is in Rajasthan. They won't go beyond this. This is much more than what you will ever be asked. This is about the different structures that we have. There are also many mythological ones, but those are not proven as of now. You might have heard of different kinds of like there is a Shiva crater, okay, think somewhere in Maharashtra or somewhere. So basically they have a mythological story around it. So those are still under testing. These are the 4 confirmed ones. Okay. Okay. I think this is it. That's it. Class